Hello and welcome to the Nerdy Things channel.
A smart home isn't just a collection of controlling devices, it also includes a network of sensors. For example, to be able to control a heating system effectively, we need to monitor the temperature in various building zones. So today we are creating a mesh of thermometers connected to a Wi-Fi network. And we are developing a mobile application for both iOS and Android platforms to see the temperature in different rooms. We will utilize multiple ESP devices equipped with DS18B20 temperature sensors. For cross-platform app development, we will leverage Flutter due to its capability to create a straightforward yet powerful application for these purposes.
Let's start with system design. There are dozens of ways to implement such a mesh. There could be solutions with servers, with sockets, HTTP requests, etc. I've decided to make the system without any servers, and this mesh will not overload the Wi-Fi network no matter how many sensors we have. We'll use UDP broadcast to exchange data between clients and sensors. If you don't know what UDP or TCP is, I would recommend watching video in the description. It will explain the basics of these protocols. In a nutshell, we have a cross-platform mobile application that sends a broadcast message to the network and asks, are there sensors? And each particular ESP device receives this message and answers to the network, yes, I am sensor and my temperature is. Sensors answers with the same broadcast message, so all mobile applications will receive this message. And of course, mobile application will update the UI and will show temperature to the user. From hardware part, we will need ESP port with Wi-Fi, DS18B20 temperature sensor, and some charging adapters and cables. We have two options with temperature sensors. The first option is the easiest. It doesn't require to solder anything. We are using a temperature sensor with a module that has a resistor on a board. We need to plug in jumper wires into pin, and that's it. The connection will be from ESP 3 volts port to module VCC male, and from module VCC female it will go to red wire of our thermosensor. The next connection will be from ESP ground to module ground, and from module ground to black wire. And the last one from ESP D17 to that pin of the module, and from that pin of the module to yellow wire of the DS sensor. Let's look in real life. So let's open our ESP board. And now we can open our temperature sensor, and we see that we have a module and we have a wires of the sensor, so it shouldn't be hard for us to connect everything together. Let's grab some wires with different colors and plug in to the module. Approximately it will look like this. And now let's use a screwdriver and screw the temperature sensor to the module. As we can see, yellow wire goes to that, red to VCC and black to ground. On the ESP, our pins located in the top right corner. We have used pins 1st, 2nd and 7. That's it for the first option. This hardware is ready to go. We can install our software and test in real life. The option number 2 is the same DS18B20 sensor, but with the soldered resistor between VCC and that channel. We have used the same pins of the board and connected them to the same wires of the sensor, but between red and yellow we have a resistor. Now let's solder it together. We have 3 wires of our sensor. And now we are connecting a resistor to yellow wire of our sensor. If we solder it, it will last forever. Here we can see a soldered resistor between yellow and red wires. Let's grab some female jumper wires and cut them in half. We will use these connectors to plug in the sensor into the ESP board. We soldered a black female jumper wire to our sensor. Same trick with the red one. Last but not least, we added a yellow wire, and now we are ready to use our electrical tape. It's very important to isolate wires from each other. If they short, you will damage your ESP board or laptop or both. In the end, we have the temperature sensor with female connectors. It could be connected to the ESP board in the same way as previous. It's time to move on to ESP software part. Let's clone the GitHub repository from the description in the video. It will take some time to download. And after, we should open ESP32 folder from freshly cloned project. Then press View and Command Palette and search for our ESP-IDF plugin. Choose Express installation and select the version of ESP-IDF 5.1.2. It's up to you whether to change installation folders or leave as is. It doesn't matter. If you see this window, it means that everything is downloaded. This button builds the project. We can press it and check that at least it runs. Of course, we see an error. It means that we forgot to configure our Wi-Fi network. Let's open nerdy Wi-Fi folder. In the folder, we see nerdy Wi-Fi config.c.example. We should copy and paste it to the same folder and rename it to nerdy Wi-Fi config.c.
Now in the new file we should put our real credential, Wi-Fi name and Wi-Fi password. It should be nerdywifi.c file, it's important. In a nutshell, UDP will send and receive broadcast messages from the local network. We have a separate video that describes how it works in details, so feel free to pause this video and search on our channel. But today we will briefly review our codebase and modules in the project. The 5 modules are included to our build process. Nerdy Wi-Fi, it's a module that's responsible for Wi-Fi connection in general. Nerdy UDP server listens to broadcast messages in a local network. If it receives something, it will notify the rest of modules about them. Nerdy UDP client sends broadcast messages to the network. The Nerdy temperature module works with our temperature sensor. It initializes it and works and grabs data from the sensor. The Nerdy MAC address module responsible for grabbing the device information, MAC address in particular. And finally, our main model. appmain.c will be run from the very first start. In this file we have appmain method and we have initialization of our operational system. After, we start a Wi-Fi connection and then we initialize a temperature sensor. You can find code in nerdy temperature module in nerdytemperature.c file. It has init method and all magic will be there. And it also has a getter. Getter returns float value of temperature from the sensor. Pretty straightforward. The next line starts UDP server. It listens to this port and you can find ports in config file. And in the last lines we start listening to events of the system. We will receive UDP messages from UDP server to this method. It calls UDP server event handler. Basically, it checks if event ID is our target event ID, and if it is, it checks the message. If message equals to string update, it will send a message to UDP client. And here we have a message with MAC address and temperature, and it calls our modules and get real temperature from our temperature sensor. And that's it. Now we can build and install our operational system on ESP board. Make sure to connect it via USB cable, and now we should select connection. We can check here, yeah, and it's not recognized yet. Let's connect again. Yeah, we see it. Okay, we can select it and press the magic button that will build, flash and monitor our ESP device. Here we see messages about initialization of flash and some Wi-Fi and GPO messages here. This message is about UDP server and the message about ESP IP address. So ESP works and now it's time to test it. Let's open Wireshark application. You can find it in the description of this video. And try to send some UDP broadcast messages to the local network from our command line. Let's type sockets UDP datagram 255 and we should type our port and set that it's a broadcast message. Now the command line waits for a message. Let's type update and press enter. As we can see, we received update in return, and also we have several messages in our Wireshark application. If we open these messages in Wireshark application, we can see that some of them are update messages and some of them contains real data from the ESP device, like MAC address and temperature from the sensor. It means that it works and we received 5 messages. Let's try again and send other commands. No, it doesn't work, we didn't receive any new messages. And if we send update, we can see that we received status from the ESP device. Now we confirmed that ESP part works perfectly fine, so it's time to move on to Flutter and Flutter development for mobile clients. Let's install Flutter SDK. Let's go to flutter.dev website and press get started. Then choose our operational system and after choose any type of mobile device. It has software requirements and also it has instruction how to install the Flutter SDK. We will need to install Flutter SDK and set up our Android Studio. So first step is download SDK. The second step is configure Android development in Android Studio in particular. When we complete all these steps in installation, we can run Flutter Doctor in command line and check if everything is fine with our setup.
So we should open terminal or command line and type Flutter Doctor and see what it will print in the command line. It will take some time to check everything, and if we see green marks, it means that everything's set up correctly and we are ready to open our Android Studio.
Okay, let's review our Dart project. We can click on folder icon and open project structure. And it's important that we opened the mobile web clients folder, not the root. And let's open our structure, our tree, and we see that we have lib folder that contains all classes that's related to our application. Our entry point is main.dart. We need to install dependency. Just click get dependency if it asks. When the app starts, main method will be called and main application will be created. This application has sensor list page. It's a class that's responsible for everything in UI. We have for UI a separate package within our components. Let's open sensor list page and we can see that we have UDP server here and we have sensor repository. On the initialization of our UI, we will start the server and send update request to our ESP devices. If we click on start, we will open UDP server. The file is udp server. And we will call this start method. It will start listening to a port. You can find ports in the top of the file. And we can see that if we receive any message, it will be printed into the output. And if we receive ping, for example, we will answer pong. So the rest of the messages will be passed to temperature sensor repository, which is located in repository folder. We can open it and see that it will print message, and then it will get device name from settings, and then it will update our UI. It will put the sensor into hash map and then call update list, and in update list it will put our list into the sensor controller. Sensor controller is a stream and UI listens to the stream. If we open page sensor list file, we will see that we have a widget that uses this stream in build method, and that this widget uses listview.builder that actually use sensors, and it will show each particular sensor in this UI. Let's connect Android phone with Type-C cable and see how we can build it. It's important to run application on the real device that connects to the same local network. If we use emulator, it could miss all UDP messages and we will spend a lot of time on debugging. Now open the terminal and type flutter run release. It will build a release build and install it on our device. The build process will take some time. Luckily we can cut it in the video. The app has been started and we see that it received some events from the ESP devices in my local network. This JSON we have seen in ESP operational system. We print it here and we also print it in message received methods in received. It has MAC address, it has temperature, it also updates the UI. If we click on the item, we can rename it to something meaningful. For example, room number 1. And that's it for Android. If you want to run this application on iPhone, it requires Xcode application that requires MacBook. So, if your current operational system is macOS and you have MacBook and you can connect your iPhone with cable, let's do it. And run flutter run release command. This time, this command will ask us which device we want to use with our build. I will choose 2 because it's my iPhone, and I will wait for a bit for a build, and eventually it will launch the application on my iPhone.
Finally, we see some data from our iPhone. We can see same temperature, same MAC addresses and a lot of devices. Let's put all devices in one place and see it in action. So we have our Android phone and iPhone. Also we have our first ESP device with thermosensor. Let's power this device. And the second set with same configuration. Also power it. Last but not least, the third configuration with same devices. When we powered everything, we can press update button in the application. And as we can see, both applications received data from all sensors. Now let's play with sensors data. We can pull to refresh to update it. And let's put our thermosensor into cold and hot water and see if the values changed. We can pull to refresh. Yeah, we can see slightly the temperatures goes up on one sensor and goes down on the another, on both iPhone and Android application. And that's it. Another step to a smart home is done. We can easily receive data from several sensors from different rooms and see everything on our iPhone and Android application. Thanks for watching and have a nice day. See you!